Have you ever stopped to consider that the future of global power might not lie in space, but hidden deep beneath the ocean? While everyone's eyes are fixed on Mars and the stars, there's a silent world, nearly 36,000 feet below the surface, that could decide who will lead the 21st century. And this world isn't just a scientific mystery, it's a strategic piece on the international chessboard. The Mariana Trench discovery isn't just a technological feat. It opens the door to mineral riches capable of redefining economies, digital routes vital to the internet, and even invisible military advantages. While the United States scales back investments, China is accelerating like never before, turning deep-sea exploration into a weapon of global influence. What once seemed like science fiction is suddenly shaping the present. And here's the most provocative part. The seafloor could become more contested than the space race. Imagine a territory with energy, resources, and information power on an unlimited scale. The big question is, who will get there first, and what will they be willing to sacrifice to dominate this hidden universe? Earth holds within its depths mysteries that few have dared to confront. Imagine an abyss nearly 36,000 feet below the surface, where no light ever reaches and the pressure is so crushing it could reduce an ordinary submarine to metallic scraps. It's in this hostile environment that the fascination with the Mariana Trench discovery is born, a scientific and strategic challenge that redefines what we mean by exploration. While for many this place seems unreachable, some see it as the next frontier of human progress. What stands out is that, in the midst of such a harsh setting, deep-sea exploration has ceased to be just a scientific curiosity and has become a contest for power. When it comes to major global moves, the eyes of the world turn to those who dare to go first. In recent years, China has surprised the world by intensifying its efforts in this almost untouched territory. Instead of treating each descent as an isolated achievement, it has begun shaping a long-term strategy, submersible robots, plans for seafloor bases, and a technological race that challenges historic rivals. The expression China Geopolitics Ocean has never made more sense than it does now. Meanwhile, on the other side of the globe, the United States has chosen to cut a significant portion of its investments in ocean exploration. It's like watching a race where one competitor speeds up while the other slams the brakes. This difference in pace creates room for Beijing to move ahead, gaining experience and shaping the future of underwater exploration. This reality forces us to reflect. If the deepest ocean was once seen as unreachable, why has it now become the stage for global strategy? The answer lies partly in geography, but also in science, and that's exactly what leads us to look more closely at the Mariana Trench. The Mariana Trench is, in itself, a deep scar at the bottom of the ocean, located in the western Pacific near Guam. Stretching nearly 1,500 miles, it holds the deepest known point on Earth. This extreme place is not just a line on nautical maps, but a natural laboratory that draws scientists, governments, and corporations alike. The Mariana Trench discovery is, in fact, a gateway to the unknown. The ocean is not a uniform mass of water, it is divided into distinct layers. Each zone has unique characteristics, from the sunlit surface to the frozen abyss where life seems to defy every rule of biology. Understanding these layers is crucial not only for science, but also for those seeking strategic dominance through deep-sea exploration. In the shallowest zone, life flourishes with intensity, but as we descend, pressure rises and light vanishes. This gradient makes every meter a new challenge. It's no exaggeration to say that the Mariana Trench itself serves as a mirror of life's resilience and a reminder of the planet's vastness. The connection with China Geopolitics Ocean emerges here, because mastering this space also means mastering invaluable knowledge. For those who think only in terms of numbers, its location also sparks more pragmatic ambitions. The seafloor holds rare minerals and compounds that could be decisive for the future of technology, as we'll see further on. This is where underwater resources mining comes into play, tied to the pursuit of wealth in places once deemed unimaginable. The trench's geography, therefore, is not just a technical detail, but a piece of the global chessboard. When we look at this immense fissure in the planet, One feeling is clear: the Mariana Trench is not just a geographic point, but a portal that leads us to reflect on the different oceanic zones and the life that endures within them. After all, what happens when we dive layer by layer into the submerged universe? When we look at the ocean, it may seem like one vast, uniform blue mass. But in reality, it's divided into zones that change dramatically with depth. The first is the photic zone, which extends down to about 650 feet. Here we find colorful corals, shimmering schools of fish, and even sharks hunting in the sunlight. For those who dive in tropical waters, this is the visible and enchanting side of deep-sea exploration. Descending further, between 650 and 3,300 feet, we reach the twilight zone. Light fades, pressure becomes 10 times greater than at the surface, and strange creatures appear, like the oarfish, which can reach up to 30 feet, or the delicate sea angel, almost transparent. Studying these organisms is as crucial for science as it is for understanding the future impacts of underwater resources mining, since any human activity here could disrupt this fragile ecosystem. Below 3,300 feet lies the midnight zone, a realm of complete darkness. Here, life depends on bioluminescence. The giant squid, for instance, flashes blue light into the water, while the blobfish has gained fame for its unusual appearance. For the Mariana Trench discovery, observing these organisms is like studying another form of life, with potential applications in biotechnology. It's a reminder that the ocean holds unexpected solutions to today's challenges. At around 13,000 feet, we enter the abyss. Almost nothing survives here, the cold is extreme and food is scarce. Yet, phenomena such as marine snow, or organic debris falling slowly from the surface, sustain some life. And when a whale dies and sinks, it creates a whale fall, a temporary ecosystem that can last for decades. This process even sparks debates in China Geopolitics Ocean, as it shows how a single isolated event can ripple into collective impact. Finally, we reach the Hadal Zone, below 20,000 feet, found in trenches like the Mariana Trench. Pressure here is 600 times greater than at the surface, and yet life still persists. The deepest point, Challenger Deep, has been explored only a handful of times, from Jacques Piccard in 1960 to James Cameron in 2012. Today, explorers like Victor Vesovo continue to descend there, linking science, power, and even the security of undersea internet cables known as submarine cable security. For a long time, reaching the ocean floor was a privilege reserved for rare missions, extremely costly and fraught with risks. In 1960, when Jacques Piccard and Don Walsh descended in the Trieste, it felt as though humanity had touched the impossible. Decades passed with little change until James Cameron repeated the feat in 2012, yet these still sounded like isolated adventures, closer to personal triumphs than to a structured deep-sea exploration program. The real turning point came in 2020, when China unveiled the manned submersible Fenduji. Unlike earlier expeditions, this project wasn't conceived as a one-time visit, but as the start of an ongoing journey. The vessel dove to Challenger Deep and returned with valuable data, cementing the Mariana Trench discovery as part of a national strategy. Beijing made it clear it didn't just want to explore, it wanted to remain. Another key detail lies in the use of autonomous mini-robots. These small machines, equipped with high-precision sensors, can map unexplored regions, collect samples, and even monitor signals of potential underwater resources mining. The big difference from the past is repetition. It's no longer about isolated experiments, but about routine missions, almost like sending probes into space on a regular basis. This shift also reveals a strategic mindset. Turning isolated missions into a continuous policy is a way to build expertise before any other country. Here is where China Geopolitics Ocean comes into play. Mastering seafloor logistics also means mastering the knowledge of how to keep it under surveillance. It's like training in the most difficult terrain to later apply those skills anywhere in the world. Interestingly, while China accelerates, other nations still see this field as an academic luxury. This difference in vision creates a gap. not as deep as the trench itself, but just as significant. And it raises a question worth pondering. If we're already discovering new ways of exploration, what else might lie hidden beneath miles of water? The seafloor is not just a place of mystery, but also a vault filled with hidden treasures. Among the most fascinating discoveries are the so-called cold seeps, areas where gases and liquids leak from beneath the seabed, creating ecosystems that thrive on chemical energy instead of sunlight. Some scientists even compare them to extraterrestrial environments, reinforcing how the Mariana Trench discovery could inspire the search for life on other planets. Another striking feature is the presence of methane hydrates, popularly known as fire in ice. These are crystals formed by the combination of gas and water under high pressure. Studies suggest they hold enormous energy potential, but also a serious risk. If released uncontrollably, they could trigger environmental disasters. This is where deep-sea exploration stops being just science and directly touches on global climate security. In addition, polymetallic nodules have captured the attention of governments and corporations. These rocks, rich in cobalt, nickel, copper, and manganese, are critical raw materials for electric car batteries and renewable energy systems. In other words, what lies tens of thousands of feet below the ocean could be the key to the energy transition the world is striving for. It's no wonder that underwater resources mining has become such a debated issue, but every opportunity comes with a dilemma. Deep-sea mining could release sediment plumes, suffocate fragile ecosystems, and wipe out life forms that took thousands of years to adapt. Imagine destroying in a few months what nature shaped over eons. That's why scientists warn that any step in this direction must be taken with caution, a concern that even influences debates about China's geopolitics ocean. These discoveries reveal that the deep ocean is not just a territory to be explored, but also an arena where economic, scientific, and strategic interests intersect. And that leads us to a new question. How are these resources shaping China's long-term ambitions on the ocean floor? When it comes to ambition, China makes no secret of its plans to turn the ocean floor into a zone of continuous control. Among its boldest projects is the development of permanent underwater bases, installed at nearly 6,600 feet deep. These structures would serve not only for scientific research, but also to expand China's geopolitics ocean, establishing a fixed presence in a space once thought unreachable. Another major front is the construction of a fleet of specialized autonomous robots. Equipped with sensors, mechanical arms, and advanced communication systems, they can operate for weeks without human intervention. This allows not only the monitoring of ecosystems, but also tasks related to underwater resources mining. It's as if China were assembling an invisible army on the seafloor, ready to act where other countries cannot even reach. The cornerstone of this strategy is time. While others are still debating budgets or hesitant to join the race, Beijing is already accumulating data, experience, and technological mastery. This early advantage mirrors what happened in the space race. Those who arrived first reaped the most valuable rewards. In the case of the Mariana Trench discovery, it's not about planting flags, but about building infrastructure step by step. By contrast, the United States has scaled back investments in ocean exploration, including funding cuts to NOAA, the National Oceanic and Atmospheric Administration. This difference creates a dangerous gap, since while China turns deep-sea exploration into a state-driven strategy, other nations seem to approach it with the pace of scientific curiosity. It's an imbalance that could shape not only the coming years, but the coming decades. Thus, an inevitable question arises: if China is advancing so quickly, what will be the implications of this constant presence in the depths? And beyond that, how might it affect one of the most sensitive issues of our time, the security of the invisible infrastructures that keep the world connected? The seafloor, as silent as it may seem, is becoming a stage for strategic disputes. It's no longer just about science or deep-sea exploration, but about a race to control critical infrastructures. A clear example is the submarine cables that span the globe. More than 95% of global internet traffic flows through them. Without these cables, there would be no international banking transactions, video calls, or even access to digital platforms. This is where the weight of submarine cable security comes in. In recent years, reports have surfaced of Russian vessels spotted near key cable routes. At the same time, China has revealed research on a prototype cable-cutting robot capable of directly interfering with these vital lines. This paints a scenario where China Geopolitics Ocean goes beyond mineral resources and extends to the invisible infrastructure that keeps the world economy running. Think about it, a single severed cable can cause billions in losses within days. Documented cases already exist, such as the accidental cut of cables in the Mediterranean in 2008, which shut down internet access for entire countries for hours. Now imagine this being used intentionally in a conflict scenario. That's why submarine cable security has become a central topic at national security tables. This dispute also shows that ocean exploration is not merely an environmental or scientific concern. It is directly tied to digital warfare and national sovereignty. Even the Mariana Trench discovery, once seen as just an engineering milestone, is now viewed as part of a larger strategy. Whoever controls the seafloor controls not only resources, but also the flow of information. The pressing question remains, if the seafloor has already become an arena of invisible tensions, what will the future of this race look like? What will happen when science, economics, and military power increasingly converge in the ocean depths? Deep-sea exploration, once admired for unveiling bioluminescent creatures or exotic landscapes, now carries with it debates over global power. It's as if every descent toward the Mariana Trench discovery were also a step toward a new world order. This progress also brings an important warning. Unique ecosystems, shaped over millions of years, could be destroyed in just a matter of months because of underwater resources mining. Scientists warn that the environmental impacts may be irreversible, and every intervention must be carried out responsibly. It's a dilemma that goes beyond China Geopolitics Ocean, touching on the very future of our planet. Still, the strategic appeal is far too strong to be ignored. Whoever dominates this frontier will gain access to mineral wealth, technological breakthroughs, and even the military advantage of controlling critical regions. For some experts, the security of submarine cables is only the beginning of a larger game where submarine cable security intersects with disputes over natural resources. The big question that echoes is this: are we witnessing a new chapter in human history where the deep seas become the Earth's equivalent of inner space? The answer may be closer than we think, especially when we compare this race to what is already happening in outer space. Many call the seafloor the inner space of Earth, and it's not hard to see why. Just like in outer space, deep-sea exploration demands cutting-edge technologies, vehicles able to withstand extreme pressures, and teams willing to face the unknown. The difference is that instead of looking upward, we look downward, toward places like the Mariana Trench discovery, which challenge even the boldest imagination. The technological hurdles are strikingly similar. In space, engineers must design capsules that endure vacuum and freezing temperatures. In the deep ocean, the problem is the opposite: crushing pressure, total darkness, and plunging temperatures. In both cases, the tiniest failure can mean the loss of billions of dollars and years of research. This explains why both space and ocean exploration often serve as testing grounds for innovations that later make their way into everyday life. For many nations, investing in space and underwater missions is also a matter of image. When James Cameron dove into Challenger Deep in 2012, his feat was compared to a journey to the moon. Meanwhile, China, by turning China Geopolitics Ocean into a state-level strategy, seeks to send a clear message. Just like in space, it doesn't merely want to participate in the race, it aims to lead it. Another interesting parallel lies in the role of international collaboration. In space, we have the International Space Station, a symbol of cooperation among rival countries. In the ocean depths, there is no equivalent. Each descent is almost always carried out by a single nation or company, with collected data often kept private. This raises the question, will we one day see a submarine ISS? And how would that affect submarine cable security or even underwater resources mining? This comparison leads to an inevitable reflection. If the deep ocean is so similar to space in terms of challenge and potential, will the race for its conquest follow the same path of intense rivalry? Or will we see surprises from new actors willing to share this invisible territory? It would be a mistake to think that only China and the United States are competing for dominance of the deep. Japan, France, and Russia are also advancing with their own deep-sea exploration programs, each with distinct goals and strategies. Japan, for instance, is mapping polymetallic nodules to reduce its dependence on imports. France is betting on underwater robotics, while Russia maintains strategic projects that mix science with defense, all keeping a close eye on the implications of the Mariana Trench discovery. What's interesting is that this race doesn't happen in silence. Each country uses its progress as a diplomatic tool. When Japan announces the collection of samples from deep-sea zones, it sends a message to the world about its energy autonomy. China, by showcasing technological strength in the depths of the Pacific, bolsters its image in debates over China Geopolitics Ocean. These programs also raise questions about strategic alliances. Imagine Japan and France joining forces in marine research projects, or even European private companies supplying technology for Russian expeditions. Such cooperation could accelerate underwater resources mining, but it could also generate new geopolitical tensions. After all, every resource extracted from the seafloor has the potential to reshape global energy and technology supply chains. At the same time, some countries still hesitate to invest, whether due to lack of resources or internal priorities. But history shows that those who arrive late risk becoming dependent on those who already control the territory. And in the case of ocean exploration, that dependence will not be only scientific, but also economic and even military. This is where the comparison to the space race resurfaces, highlighting how every step taken in the depths echoes into the global future. Thus, the picture emerges, multiple players competing and cooperating at the same time, each pursuing its own interests. Which brings us to the inevitable question, if so many nations see strategic value in the seafloor, how will this impact the world economy once these resources begin to be exploited on a large scale? The seafloor has increasingly been called the new oil, and that's no exaggeration. The rare mineral deposits found in areas like the Mariana Trench have the potential to redefine global production chains. Elements such as cobalt, nickel, and manganese, present in polymetallic nodules, are essential for electric car batteries, wind turbines, and even smartphones. The Mariana Trench discovery puts on the table the possibility of a new economic cycle, one that could shape both nations and private companies. Think about its impact on a practical scale. Today, much of these minerals come from African or South American countries with long and often unstable supply chains. If underwater resources mining advances, this dependence could be reduced while new power hubs emerge in the Pacific. For China Geopolitics Ocean, this means not just exploration, but control over a strategic resource that could shift the balance of global exports. Exploration, however, is not just about extraction. It involves enormous costs, advanced technologies, and environmental risks. That's why experts believe only international consortia or major powers will realistically have the capacity to operate at such depths. This could deepen inequalities. While some countries dominate deep-sea exploration, others remain dependent, with no access to these resources. The ripple effect reaches our daily lives. Imagine the price of an electric car dropping because the required minerals are more accessible. Or, conversely, rising because a single nation decides to monopolize production. It shows how what happens 36,000 feet below the surface can influence the economy of your own city. Even submarine cable security comes into play. Without safe infrastructure, both extraction and the transmission of data about these operations would be compromised. What becomes clear is that the seafloor is not just the next chapter of science, but also one of the biggest economic baits of the 21st century. And here lies the central question: if exploration can redraw the map of global wealth, who will have the power to write the rules of this new game? Now that you've uncovered the secrets behind the Mariana Trench discovery, it's clear we're facing something far greater than mere scientific curiosity. The seafloor has the potential to reshape economies, shift alliances between nations, and even define the balance of global power. Think about how every technological leap has already transformed your life without you even noticing, from the phone in your pocket to the internet that connects the world in seconds. If the deep ocean is the next frontier, wouldn't it be wise to start preparing to understand its impact? Those who master information also master the chance to stay one step ahead. And here's my challenge to you. Do you believe this exploration should be a race between world powers or a journey of international cooperation? Share your opinion in the comments. Your perspective could enrich this debate more than you realize. If this content sparked your curiosity, subscribe to the channel and turn on notifications. That way, you'll keep following the next chapters of this silent race that could change humanity's destiny. After all, the future is already being written, and it begins in the depths of the ocean.